Here's our next example. Let's see if we can go through this without quite so much explanation here. Step one, we're going to verify this with a delta epsilon proof. So number one, let epsilon be greater than 0. Number two, search for delta. I'm not writing this because I have extra chalk I need to get rid of. I'm writing this because you need to write this every stinking time. You need to write this every stinking time. Search for delta. You start at the end. You start with absolute f of x minus L to be less than epsilon. Plug in the values. F of x is this is it. L is 4. All right, maybe you want to pause the video now and see what you get for your epsilon, or what you get for your delta. So can you see what you get for your delta? All right, so we're back. See if I can match what you did here. So what do? We're gonna try to create x minus a, which in this case is x minus 2. That's our task, is to create x minus 2. So this is absolute negative 3x plus 10 minus 4 is plus 6. But now I need to create x minus, I need to factor out not 3, negative 3. And we know when you factor out negative 3, all the signs change, x minus 2. And sure enough, that's exactly what we wanted. It's got to work out because I'm giving you stuff that actually does work. I can't ask you to verify something that's false. I'm going to ask you to verify something that's true. And so it must work out. You just need to make sure and put all the details in the right spot. And so we got to create absolute x minus 2. So this is, continuing, this is absolute negative 3 times x minus 2 absolute is less than epsilon. And so that's absolute x minus 2 is less than epsilon over absolute negative 3. Just leave it like that because you're going to need to fix it back again later anyhow. Leave this as absolute negative x, or absolute negative 3. And is it clear? I did not divide by a negative number. I divided by absolute value. That's why we need to have this inequality stay the way it was. All right? So we choose delta to equal whatever's on the right-hand side, epsilon over absolute negative 3. And then what's left is step 3. We need to verify this delta. All right? And so to verify this delta, you start at the beginning, put in all the details. You only need this once, and so we've stated it, so now we're good to go. Absolute x minus a is worth my number 2 is less than epsilon over absolute negative 3. And now our task is to create what we started from. You work backwards to find it and work forwards to verify it. Backwards to find it, forwards to verify it. And so this is absolute negative 3 times absolute x minus 2 is less than epsilon. We're well on our way. We need to create f of x minus L. So this is negative 3x, do you see this, plus 6. And then we don't want negative 3x plus 6, we want negative 3x plus 10, right? But if you add 10, you have to counterbalance that by subtracting 10. So this implies absolute negative 3x. I better put this down here one more time. I'm going to steal one more line down here at the bottom, just for the space factor. So this is absolute negative 3x plus 10 minus 10, and then plus the 6 again. All right, plus 10 minus 10, so everything's equal to what we started with. But there's my baby. There it is. That's f of x. So this now implies absolute negative 3x plus 10. And what do we have left? Negative 10 plus 6 is negative 4, is less than epsilon. And that is, in fact, that's exactly the same thing as saying f of x minus L is less than epsilon. And the proof is finished. So that is the procedure. That's the technique. Let epsilon be greater than 0, search for delta, back solve, choose delta, and then verify that delta works the way we say it does.